Okay, so today we're going to move away from the actual physical triangles and we're going to look back at our trig functions. I want you to pull out your calculators for me and find the sine of 25 degrees and also the sine of 155 degrees. 25 and 155. 25 is what? 0.4226. 155 is 0.4226. How on earth can they be the same? What's that?
I don't know.
Yeah, if we look at our unit circle where these angles come from, here's 25 degrees. Where's its sine? Right there, right? 155 degrees is over here. Its sine is right here. Well, the reason these are the same is, what's this angle? 25 degrees. Remember we said this horizontal diameter here had a name called the what? Reference diameter. Or sometimes called the reference plane, you're right. Reference diameter. These, this one and this one, are called reference angles. If they have the same reference angle, they have the same sine. Now there are two other spots on here that have similar reference angles, right here and right here, where this reference angle here is 25 and this is 25. Do they have the same sine? Not quite. Of course, this angle right here would be, what, 180 plus 25 would be 205 degrees. This one here would be 335 degrees, right? 360 minus 25. The sine of 205 is not going to be 0.4226. It'll be a negative 0.4226 because this is below the zero line. It's in the negative direction. Guess what the sine of 335 will be? Negative. So the reason I bring this up, what if we're told that sine of x is 0.4226? How do we solve that? How do we figure out what x is?
We take the inverse.
There you go. If we're looking for the angle, we use the inverse trig function. X is going to be the inverse sine, 0.4226, which the calculator spits out as 25. Problem is, we do not know if that's 25 or 155. They both have the same sine. If we're looking at an angle like this, is the answer 25?
No.
No, the answer is 155. So if it is an obtuse angle, oops, S comes before E in obtuse. If it's an obtuse angle, it is really the result we get from that inverse sine. Then we take the supplement. So it's 180 minus the answer to get the actual angle. So when we do an inverse sine, there are always two possible results. There's the result that the calculator gives us, which is the 25 in this case, and there's the supplement of that angle. So if I tell you that sine of x equals 0.8, that's technically not enough information. If I tell you that x is acute, or sometimes I might say x is less than 90, what does x have to be? So we're just going to do what? Inverse sine of 0.8, which is 53 degrees, 53 point what? 13 degrees. There it is. But what if I tell you that sine x equals 0.65, and x is obtuse. So what do? We start out with the inverse sine of 0.65, which is, what is it? 40.54 degrees. But is that our answer?
No.
Minus
Subtract after
180.
So you're at 139.46 degrees. Very important to remember that. Now,
Will it be called out acute or obtuse?
It'll either be called out as acute or obtuse, or you'll be told x is less than 90 or x is more than 90, or you'll have a picture. And from the only way to get the picture is really tough to deal with. Is that acute or obtuse? Yeah, is that acute or obtuse? In this case, it is obtuse, but it's tough to tell.
Now, if we actually have a 90-degree angle,
Yeah.
is it going to have the right angle mark on it?
It'll almost always have that in there. Or it'll be one of those two cases, like a radius to a tangent, or vertical and horizontal dimensions intersect, where you can assume they're right. Those are two of the cases where we can assume that it's right angle. Do we have the same problem with cosine? What's the cosine of 25 degrees? Go ahead and plunge your in. What is it? 9063.
Negative. See, now this one gives me negative.
Yeah. Cosine of 155 is a negative. Let's analyze this.
So will my calculator do the negative part?
So if we have, these are our angles here, 25 and 155. Same reference angle, but remember the cosine is this dimension. For the 25 degrees, that's the positive side. For the 155, that's on the negative side. So for cosine, the supplements have different cosines. Well, they're the same cosine, just one's positive and one's negative. Yes, your calculator will do the negative. If you are told cosine x equals a negative 0.75. If you do an inverse cosine of negative 0.75, you get x is 130.
No, I got something.
What is it? Negative 138. This something seems a little off there.
I got something completely different.
Second cosine. Get my cosine. Negative 0.75. 130. Oh, you're right. 138.59.
How do you?
On your calculator, put in the negative. Remember, you don't use the subtraction key. There's a negative key down there. Down by the equal sign.
I'll be right. Use my subtraction and it not work.
Yes. So on here, what angle would have the same cosine as 25 degrees? That would be this one down here.
Do that?
That would be that one. This would be 335 degrees. That's really all we need to know is whenever you do an inverse sine or an inverse cosine, there are always two possible angles. For the inverse sine, it is the supplement, or 180 minus that angle. For the inverse cosine, it's 360 minus that whatever that angle is you get from the result. I know. In your packet, page 374. The more important thing here is the inverse sine, just so you know, because on a day really soon, like tomorrow, we're going to discuss something called the law of sines, which is where we're dealing with triangles that don't have right angles. So it's possible to have an obtuse angle in it. So you need to know that when you do an inverse sine, there might be a second possibility.